Welcome to lesson 3.8 on fractions. Now that you know how to multiply and divide fractions, we have to take this one step further and now go into doing some fraction problems. However, I do realize that it's been a long time since you've added or subtracted fractions, like a whole year. So what we're going to do is we're going to do a review of how to add and subtract fractions, and I want you to pay attention because right after we're done this lesson here, 3.7 or 8, our lesson 3.9 is on order of operations, where you have to show me all your work for adding, subtracting, multiplying, and dividing. So pay attention. You're going to have to do this again in our next lesson. So adding and subtracting fractions. So the first thing we're going to do is start with simple fractions. 1 over 3 plus 3 over 8. To do this, the first thing you need to do is to find the lowest common denominator of the two fractions. This is the lowest common multiple of 3 and 8. Now, in the old days, what we did is we had you take and go 3, 6, 9, and then, of course, 8, 16, 24, and go until you found the number that was in both lists. That is 24 in this case. If you're having a hard time with that, what does work is to take the two denominators and to multiply them. So in this case, 3 times 8 gives you 24. This is not the most efficient way of doing it. Sometimes this will get you much larger numbers than you actually would normally use. However, it is a trusted way of doing it. Mr. Vaklovic in grade 10 is going to teach you, or we're going to have you do it a little bit more efficiently to make sure you get the lowest common common denominator, not just a common denominator. So let's take a look. I've got 1 over 3 plus 3 over 8, and I want to take that and have 24 in the denominator. So if you think about it, if to get 3 to become 24 we multiplied by the 8, what you have to do is take the 1 and multiply it by the 8 also. To get the 8 to become a 24, we multiplied by 3. So 3 times 3 is a 9. So if we think about it, multiply by 8 over here, which is the denominator of the second fraction. And over here, we multiplied by 3, which is the the denominator of the first fraction. So now we take 8 plus 9 over 24, and 8 plus 9 is 17 over 24. If you had to reduce, you would have to do it. So the sum is 17 over 24. The next logical step is to increase the size of the numbers until we have a mixed number. So let's go to mixed numbers. To add mixed numbers, it's easier if we split them up. Take the whole numbers over here and add them separately. Take the two fractions over here and add them separately. And then at the very bottom, we're going to put them back together. So 3 plus 7 equals 10. That's pretty straightforward. Again, over here, denominator, 4 times 3, which is 12. And this is 3 times 3, which is 9. And the second one is 2 times 4, which is 8. So we have 9 plus 8 over 12, which is 17 over 12. Now, in this case, you cannot leave the 17 over 12 in this format because we have a whole number of 10 on the other side over there. So we have to take and convert this into a mixed fraction. So 12 goes into 17 one time, and that gives you a 5 remaining. So it's 1 and 5/12. Now you can use your calculator to do it. You don't have to do what I did. Now take the 10 and add it to the 1 and 5/12, and you'll find out that 3 3/4 plus 7 2/3 is 11 and 5/12. So our next step, here's a word problem. I'd like you to try this without my help. Bob has eaten 2 3/5 pizzas. His wife, Large Marge, has eaten 5 2/7 pizzas. How much pizza have they eaten together? There you go. Pause the recording and do this question. Okay, time to do it. Obviously, split off the 2 and the 5. That gives you 7. And now take the fractions, 3/5 plus 2/7. And 3 times 7 is 21. 5 times 7 is 35. Plus 5 times 7 being 35. And the 2 times 5, which is 10. So 21 plus 10 over 35 gives us 31 over 35. It does not reduce, and it's already a basic fraction. It's not improper, so we can just take now and bring the 7 and the 31 35ths put them together. So they've got, between the two of them, they have eaten 7 and 31/35 of a pizza. Sorry, pizzas together. All right. Now, next subtract is the numbers get bigger. Okay. Now here is where splitting them up becomes a good idea. If you don't, you're going to end up with some really big numbers. So let's take a look and have you do this one. Pause the recording and do it. All right. So you should be finished. You have 21 and 5/12 plus 43 and 3/8. The 21 and the 43 go over here. Add them, you get 64. 5/12 plus 3/8. Now this time, I'm not going to do multiplying of 12 times 8 because I'm looking at this going, wait a minute, 24 is a number that both 12 and 8 go into. To get 12 to be a 24, I'm multiplying by 2, so 5 times 2 gives me 10. 8 to 24 is multiplying by 3, so 3 times 3 is 9. So in this case, it's just 10 plus 9 over 24, which is 19 over 24. So by choosing a lowest common multiple, rather than taking 12 and multiplying by 8 and using 96, I have smaller numbers, they're easier to work with, and I get the answer fairly quickly. Now bring the 64 back in, and you have 64 and 19 over 27. And of course, if you go up here, it says here what is the sum. So the sum is 64 and 19/27. Turn your page. All right, subtraction. Same thing as we did before. Only this time, instead of putting the numerators together, we're going to subtract the numerators. So our LCM, lowest common multiple of 3 and 8, is still 24 in this case, just like previously. So we're going to have 2/3 minus 3/8, and I'm going to go to 24, which is basically 3 times 8. So 2 times 8 is 16, 3 times 3 is 9, so I have 16, take away 9 over 24, and 16 take away 9 is 7/24. So in this case, the difference is 17 or 7/24. So again, the next thing we have to do is step it up to mixed numbers. In mixed numbers, we're going to start out with splitting it up where it works, and then later on we're going to talk about borrowing. So we have 13 and 7, so I'm going to take 13, take away 7 over here, so of course that's equal to 6. And now I have 3/4, take away 2/3, and remember that in subtraction, order is important, you can't flip them around. So my denominator is going to be 12, 3 times 3 is 9, 2 times 4 is 8, 9 take away 8 over 12 means I get 1/12. Bring the 6 back into the position here, so 6 and 1/12 is what you get, so in your sentence, 6 and 1/12. You may have noticed that in the above example, the first fraction here was larger than the second one. What do we do if you have 5 1/4, take away 3 3/4? If you think about it, 1/4, you can't take away 3/4 unless you want to go into negatives, and that will give you a mixture of 5 take away 3, which is a 2, and then you'd have negative, I guess it's 2/4. You'd have a positive whole number and a negative fraction, which you can't have. So we have to find a way to get around this. Fortunately, you've done this before. If you remember back a long time ago, when we were first introduced to subtracting, the first thing you were taught was 3 take away 8. Could you do it? If you have 3 items, say 3 counters, teacher would put them on the table and say, okay, take away 8. And this could not be done because you don't have 8 to take away. So then you were taught to go next door and do either trading or borrowing. So you go over to the 2 and you get 1 from them. Now the 3 then becomes 13, and of course 13 take away 8 is 5, and of course 1 take away 1 is 0, and you get 105. We borrowed. We can do the same thing in fractions. 5 1/4 take away 3 3/4. Since 1/4 is less than 3/4, 1/4 being equal to 0.25 and 3/4 being equal to 0.75, we can actually go next door and borrow from here and put the 1 with the 1 1/4. So now I keep the 4 as one of my whole numbers. I keep the 3. So over on this side, I get 4 take away 3, which is 1. And on the other side, fractions, I have 1 1/4 take away 3/4. Now to do the subtraction, the first fraction should be turned, the first mixed number should be turned into an improper fraction. That gives me 5 take away 3 all over 4, which is 2/4 or 1/2 when you reduce it. Bring the 1 in, and your answer is 1 1/2 on your next page. So, how do we tell when we have to do the actual borrowing? Well, you have to do a quick check if it's not obvious to yourself and do some dividing. All right? You have to divide the fractions, turn them into decimal form so that you can find out whether or not you actually have to do an actual borrowing. So let's take a look here. I've got 21 and a 12th. If I take 1/12 and divide it out, you're going to find that 1 divided by 12 is 0.083. And 3 divided by 8 is 0.375. So my first fraction is less than my second. So do we need to borrow? Most definitely, yes. So how do we do that? Well, you've got 21 and the 12. Look way back up here again. I'm going to take the 21. I'm going to borrow from that. That becomes a 20. I'm going to put the 1 I borrowed with the 12th. So I have 20 take away 13 now, and that's equal to 7. And I have 1 1/12 take away 3/8. So I'd like you to pause the recording. I want you to complete the actual 1 1/12 take away 3/8. Okay, so converting this into an improper fraction, you're going to end up with 13 over 12 take away 3/8. And again, if you choose to multiply 12 times 8, you can. That'll give you 96. I'm going to actually find the lowest common denominator because it makes the math easier. I know that 12 goes into 24, and so does 8. So to get from 12 to 24, I multiply by 2. So 13 times 2 is 26. To get from 8 to 24, I multiply by 3. So 3 times 3 is 9. So 26 take away 9 all over 24 gives you 17 over 24. Now, put the two pieces together. Take the 7 and the 17 24ths, you get 7, and 17 24ths is your answer. Okay, this, you may have noticed, is a pain. There is another way to do it, and that means I have to adjust my notes a little bit. This is a method that you can use that'll help you if you don't, if you want to take out the whole decision of whether you should borrow or not. It may require that you have large numbers, and you will get large numbers. That's not a problem. This is what we're going to do. I want you to take 85 and 11 24ths. I want you to convert it to an improper fraction. Okay, so that's going to be 24 times 85 plus 11. Now you're going to get a huge number, 2051 over 24. But you have a calculator, so it shouldn't be too difficult. Now we're going to take 8 times 33. We're going to multiply that. Plus 5 gives me 269 over 8. So you can ignore borrowing this way. Now, I've purposely chosen big numbers to make you have to use your calculator. It's a tool that's not illegal to use. So now that I've got this 85 now in my improper, and this, the other one, what I have up here, the 33 in here, there's no need to worry about your whole numbers. I just have to take 2051 over 24, and I have to subtract 269 over 8. Again, one of the ways you can do this is realize, wait a minute, 8 goes into 24. So I can leave the 2051 as it is, and then just change this one. I'm going to multiply the 8 by the 3, so that becomes 24 on the bottom. And of course, 269 times 3 gives you 807. So now 2051, take away 807, all over 24. So take away 2051 means that you get 1,244 over 24. All right. So the next step to do on this one is to take and do a mixed improper fraction. I would use your ABC button on this. You don't even have to do the big, do it by hand. So take 1, 2, 4, 4, ABC, 24, and simply press equals. And you will get 51 and 5/6. Now, you may look at this and think, well, this is too much work. It's too many big numbers. But in most of your questions you're going to get on tests and on quizzes and even on your achievement tests and stuff, you're rarely going to get them giving you things like 85 and 11/24. But with your calculator, you should have no difficulty. So let's take a look at your next page. Yeah. So let's go on to the part of the lesson. That was review. If you have any trouble with what we did, I need you to go back, review it, until you can add and subtract fractions without any difficulties. Now let's go on to the lesson part of what we're supposed to be doing. This is the new stuff. Word problems. When you see the word sum, it means to add. You, by now, should know some other words that when you encounter them in a word problem, what means to add. So sum, adding, together, total, both, added, increased, by. These are things that you add by. It means you need to add. Okay. Subtracting is difference, how much more, that kind of stuff. Multiplying is product, twice as, times. Dividing is quotient, shared, grouped, halved, third. These are all words that you should be able to add words to at this point. So let's take a look at a problem from the textbook. Cassie worked on her science project for 3/4 of an hour on Tuesday and 5/6 of an hour on Wednesday. She spent Thursday finishing her math homework. First question part, how long did Cassie work on her science project together? Well, she worked on it for 2 days, Tuesday and Wednesday, 3/4 of an hour on one day and 5/6 hours on the second day. So if it wants it all together, this word all together means to put it all together. So 3/4 plus 5/6. And you can see here that they've done that. Now they leave out the step that I like you to put in, but everything else is relatively done correctly. All right, you get 19 over 12. Their method of going to mixed improper is to take the 12 from the 19 and have 7 left over to get 1 7/12. I'd encourage you to use your ABC button. How about B? The words longer. Let's take a look at the second question here. How much longer did Cassie work on the project on Wednesday than on Thursday? How much longer means to subtract. So 5/6 take away 3/4. You can have a common denominator of 12. If you use 24, you'd have 20 over 24 take away 18 over 24. When you subtract, you'd have 2 over 24, which reduces to be 1/12 anyway. So both of them will come out to be 1/12. So Cassie worked 1/12 hour longer on Wednesday than on Tuesday. Now on question C, going back for just a second here. Altogether, Cassie spent 2 hours on schoolwork over the 3 days. How long did she spend on her math homework? Well, she spent 2 hours on everything. We know that when we added these together, we had 1 7/12. We did this previously. We have to take 2 and subtract 1 7/12. Now, this particular one, I'm not really a big fan of. I think what you should do is take the 2, put it over a 1, and convert 1 7/12 into an improper fraction. So that becomes 19 over 12. And now just cross multiply like we did to get your answer. So you have 12 here, 24 there, take away 12 here, and 1 times 19 is 19. So 24 take away 19 all over 12 gives you 5/12. I think this way here is easier for you to understand based on what we've been studying than doing this kind of borrowing and splitting. Okay, let's go on to the next step. Bob worked at the construction site for 5.5 hours in 1 week. George worked 2 4/5 times as long as Bob that week. On Thursday, they both worked 2 hours. How much time did George work that week at the construction site? Now, this particular question, and you're going to get a lot of them now, where they put in extra information that you're going to have to sift through. You're going to have more information than you need to solve the question, and your job is to decide what you need to use and what you need to put aside. In this case, the fact that they both worked on 2 hours on Thursday is irrelevant, and it can be just ignored. The key word in this is right here, times as long as Bob. So we need to multiply. So Bob worked 5.5, and Greg worked 2 4/5 times as long as Bob. So you take your 5.5 and you multiply it by 2 4/5. So your job now, pause the recording and calculate the answer. All right, should be done by now. First thing you need to do is to convert the 5.5 and the 2 4/5 into improper form so we can multiply them. Remember, you cannot multiply them when they're in mixed form. So 2 times 5 plus 1 is 11/2. 5 times 2 plus 4 is 14/5. So there are your two improper to mixeds. Next, 11 times 14 over 2 times 5. 11 times 14 is 154. And 2 times 5 is 10, which when you reduce it is 15 2/5. So George worked 15 2/5 hours at the construction site that week. All right, now what I'd like you to do is kind of difficult because you're at home now. If it's to create a divide problem that involves fractions and a whole number, use 5 as the whole number and 1 2/7 as the fraction, and then give it to your classmate to solve. So what I'm going to do is I'm going to basically just shortcut the whole thing. I'd like you to take and okay, a jug holds 5 liters of juice. A cup holds 1 2/7 liters. It's a big cup, okay? One of them big, huge beer mugs, or whatever. 1 2/7 liters. How many cups can you have? Or how many cups can you fill? Okay? So if you think about it, it's a divide question. We're starting with a big, huge jug, and we want to divide it up into 1 2/7 pieces. So your job is solve the question. Okay. First things first, 5 is over 1. Can't forget that. 1 2/7 has to be changed. 7 times 1 plus 2 is 9/7. So now I've changed this into its format that I can use. I've taken the mixed and turned it into improper so I can use that. And now, because we're dividing, it's the flip and multiply thing. That gives you 5 times 7 over 1 times 9, which is 35/9. Now you have to take 35/9 and you have to take and change it into my textbook question. Actually has it the other way around, so give me a section here. 35/9. 3 8/9. So if you take a look at this, the question asks how many can you fill? You can fill 3 full, and 1 is 8/9 full. So the question, though, I think is worded how many you can fill, so your answer here is you can fill 3. All right, these are word problems, and you are to complete them. Go through them, double check them, use your calculator to verify you've done things correctly. Check the back of the book to make sure if you made any mistakes that you can find the strategies to do it. If you have any questions, come and talk to me, and we will see you in the next lesson.